Hi everyone, in this lecture we will learn about experiment and analysis, and I will teach you how you can actually measure the time of a execution of a program. Okay, so what we are going to do, we are going to learn how to actually measure the runtime. So I have a small program. So first of all, what we need to do, so every programming language comes with a library in which you can get the timestamp. Okay, uh, let's say in C++, this library we have is C time. Okay, and what we can do is, using this library, we can note what is the start time. Okay, so it will return us some timestamp. Okay, and let's say what is the time currently when this line number 20 is executed. Maybe this time is something like 11864889, something like this. Okay, so this is a timestamp. Okay, and it actually denotes, we can convert this timestamp into current date and time. It is with reference to certain date, maybe something of 1982 or something like that, but we can definitely convert this into today's date, whatever it is. Let's say 8th of July, and the time is like 6 p.m., uh, 40 minutes and 384 milliseconds, something like that we can do. But what we can do is, we can actually call the clock method and it will give us the current timestamp of the system. Okay, and what then after that, what I'm going to do, I'm going to note how much time this sort function is going to take. So I've created an array. I'm not noting down the time of creating an array, I'm going to just note down the time of sorting an array. Okay, so I call the sort function on this particular array. Okay, and this will tell me, okay, this array is going to take this much time. So we do the sorting of the array, and finally we are going to note what is the end time. Okay, when the sorting is finished, then line number 22 to will execute, we will note down the end time. That is also the current time of the system. And finally, if you do end time minus start time, you will get to know, okay, this is the time that is taken by the algorithm to run for a given input. So I'm going to accept the number of elements from the user, and for different inputs we are going to check whether the time remains same, does it changes, and if it changes, by what factor it changes. Okay, so let's run this code. Dot slash time compare. Okay, I need to build it first. Okay, let's build the code first. Yes, it has been built, and now we can run the code. Maybe I say, okay, I just want to run it for 10 elements, then the answer is 11 milliseconds. Okay, and every time you're going to run, it is going to vary slightly, because it's not that accurate. During when a process is executing, the CPU also switches to some other tasks as well. Okay, but now you can see it is somewhere around 6. So maybe I can write that time taken by this merge sort for 100 element is, let's say, 10 milliseconds or microseconds, whatever is the unit. I'm not sure, but now let us run it for 100 elements. Okay, so it almost remains same. It is almost like constant. So maybe this was 6 and this was 10. Okay, and maybe I also try to run it for, let's say, 1000 elements. Then it is going to be uh, sorry, so let me do one thing. We started from 100 elements. Okay, so we don't have the table for n equal to 10, so let's start from 100, because 10 is a very small number to sort. So this took 10 time and this 1000 took 13 time. Okay, and now let us do it for 10,000 elements. Okay, and it took 47. Okay, let us do it for 1 lakh elements. It took 414 time. And let us do it for a million elements, and it took 2179 time. Okay, so you can see the time is growing as we are changing the input size. Now the same thing we can run on bubble sort, which is a different type of a sorting algorithm. So what I'm going to do, I have this code for the bubble sort ready, and I will not print the array. So I will what I will do, I will do the same thing here. I will include the library hash include c time, and I don't need this comparison here, and I have to create an array. So maybe I can simply uh, copy this thing here, or I can actually copy the algorithm from this file in this file. Okay, and instead of calling the merge sort, we can actually call the bubble sort method. So here we are using a vector instead of an array, which is fine. And okay, so we have this vector which is passed by reference. All right, all right. So instead of calling the sort function, we are just going to change the algorithm. So we are going to change bubble sort array and n. Now we are going to this is a okay, compare method was used here, so we can actually copy this method and paste this method here as well. Fine, so bubble sort code is ready, and now we can note down how much time this bubble sort is going to take. So let's build the code and let us try to run this file again. So first we are going to run it for 100 elements, and it took 142 milliseconds. Okay, so now you can definitely see there is a huge difference between merge sort and this bubble sort. Then let's run it for 1000 elements, and it took 6325 milliseconds. Okay, and then we are going to run it for, let's say, 10,000 elements. It took 508902. Okay, 508092. Okay, a lot of time. Let's increase our input size by a factor of 10, and now you can see for 1 lakh elements it is still running, and it's going to take a lot of time. Okay, so let us wait this alright, so it took a lot of time. I paused the video so that you don't have to wait to see the result. So now you can see that what actually happened is we changed our input from, let's say this was n to 10n, and you can see the time actually almost grew by a factor of 100. So this went from n to 10n, and time went from t to 100 times of t. That means uh, so that means the bubble sort is actually following a quadratic complexity. Okay, so this time is how much? 4949 uh 506410. Okay, 506410. So that is a huge time. We have to wait for a lot of time to see this result. Now if I run it for 1 million elements, this gave me very quick result, but for this the order would be something 100 times of the previous result, because again we are increasing our input size by a factor of 10. So that means it would be huge time. It would be few minutes we have to wait to get the sorted array. So that's something you should not be doing for every problem. So you should be able to estimate how this factor came or how this factor came. That is what we are going to learn. So this growth factor is actually a n log n factor. We will learn why it is n log n and how it is n log n. But here you can observe this time is proportional to n square. Okay, that means if input changes by a factor of 10, the time will change by a factor of 100. So this is what experimental analysis is, and this is what we will learn in this particular section. Okay, so that's all for this lecture. Thank you.